Hello students, welcome once again to our series, and that's the question of limits here. See, that's a series, okay, and n approaches infinity. So normally what we think while looking at this type of question, and I think we have already used it, okay, at one or two places, that we can solve this series with the help of definite integration. So that's for sure a method we give a try, okay. But for that and for any case, if you have a question of series, the first step according to me, and by now all must be knowing it, is to write the general term. So let's write it as a series form and summation form. So limit as n approaches infinity, summation as r goes from 1 to n, in numerator is 1 to 3, so it's r, and in denominator 1 to 3, so r plus n square. Now see, if we have to get it in the form of definite integration, so we should be able to compare it with this limiting form, which is limit as n approaches infinity of 1 by n into summation of f of r by n. Bachcho, r goes from 1 to n here, okay. And in that case only we say that this is nothing but integral from 0 to 1 f of x dx. Isn't that the point here? Is we need 1 by n out of summation sign, and within summation, within function, wherever you have r, it should be only a function of r by n, and there shouldn't be any extra r or extra n left anywhere within the summation or within the function, okay. Now if I try to write it in that form, so limit as n approaches infinity, so the simplest thing I can see here is why not to get 1 by n. So for that I will take n square common here, okay. So I will be taking n square common here, and then what do we get? So we have 1 by, I am taking n out of it and taking 1n to the numerator to balance it. The problem is r by n square plus 1. That's the problem. See, numerator is well settled. Numerator is the form of r by n, but is denominator term a function of r by n? Of course not. It is r by n square. That's what I said. There shouldn't be any extra r or extra n here. What does that mean? That simply means I won't be able to apply definite integral to evaluate this limit. So that's the first point in this question. Okay, now what? If we can't do it, then my suggestion is simple. Go for sandwich theorem, okay. So I will write summation r upon r plus n square will be less than summation r upon, see, whenever we have a summation, the problem is not presence of r or r square in the numerator. The problem is its presence in the denominator, because if there would have been no r in denominator, I can easily apply summation formula, summation r square, summation r cube, summation constant, whatever. Isn't that okay? So let's take care of this r. So while writing it, see, it will be less than, of course, when denominator is minimum, the entire expression is maximum. So minimum value of r is 1, so I will replace it with 1 plus n square, and then it is greater than r upon, of course, when denominator is maximum, the value is minimum, so n plus n square. But is it sufficient? Of course not, okay. So I will be putting here summation sign also, because that's the summation everywhere. Now that's it. Okay, now let's solve the summation. So we get here summation r, see, denominator is a constant, okay. So its summation of r is n into n plus 1 by 2, n into n plus 1, see, wow, is less than summation r upon r plus n square. We can't do anything with this. Less than summation of r, which is n into n plus 1 by 2 times 1 plus n square. Okay, now let's apply the limit, because that's what we have to evaluate. Limit as n approaches infinity, limit as n approaches infinity, limit as n approaches infinity. Fine. Now if we get these two limits as exactly same number, then we can easily claim by sandwich theorem that the limiting value of this function as n approaches infinity will also be the same, because it lies ultimately between these two extremes, okay. So now it's infinity by infinity form, and we know in infinity by infinity form that if the degree of numerator and denominator match, then the value of the limit is ratio of the highest degree terms in both numerator and denominator. So in numerator degree is 2, in denominator degree is 2, so the ratio is half, so this value is nothing but half. In ILSS there is nothing to do, they get cancelled. Even if they don't get cancelled, then again the new n square, and in denominator also you have n square, ratio of coefficient is half. Since the left extreme and the right extreme has same limiting value, hence the limiting value for this is half. So the answer for this one is, bacho, how much? Half. Okay, so that's the question. With the help of sandwich theorem we could evaluate this limit here.